Welcome, everyone, and thank you for joining us for today's webinar, Kublai Khan, Blockchain and the Democratization of Identity. I'm Shay Mann, and I will be your moderator today. Today's webinar is in listen-only mode, so if you have any questions throughout the event, go ahead and submit those in the Q&A panel, and we will answer them during the Q&A session at the end of the presentation. This session will be recorded, and we'll email you a link to the recorded version tomorrow. Joining us today is Darran, CTO and CISO here at SailPoint. Darran, we've got a lot to cover today, so with that, I'll pass it over to you to get us started.
Great, thank you, Shay, and good morning, good afternoon, good evening, wherever you might be in the world. We did a little audio test, and hopefully you can all hear me clearly. As Shay said, I'm our CISO and our CTO here. And the topic today really, you might say, doesn't touch either of those. Obviously a very catchy and interesting title. The slides themselves run for about 30 minutes. And I'll leave us plenty of time for some Q&A at the end. And much as I sit through many webinars myself, having some time back at the end is always good. So I'm going to guess you're going to get 10, 15 minutes back at the end. But for the time I do have, I'm going to tell you a story, and that is a story of Kublai Khan, blockchain, and the democratization of identity. Now, I'm going to guess that most people have heard of Genghis Khan, and he was the founder of the great Mughal empire of the 12th and 13th century. Opinions are mixed. Some say that Genghis Khan was the most brutal military leader of all time and responsible for the death of, some say, 20 million people. So that's a pretty severe statement. Others will say that he was actually a military genius who dominated his enemies with horse-drawn cavalry, with fear, and with intimidation. However you view his history, he certainly made a mark upon it. In less than 20 years, phenomenally short amount of time, he went from leading a few tribes on the plains of Mongolia to ruling over what really was the largest land empire the world has ever known and maybe ever will again. Now, Kublai Khan was Genghis Khan's grandson, and he took over control of the empire in 1260. Like his grandfather before him, he was absolutely a Mongol warlord himself, but he turned out to be a very different type of conqueror and a different type of man. Due to the influence of his mother, Kublai was schooled in Confucian Taoism as well as warfare, which is very unusual at that particular time. And although he continued to engage in military conquest for most of his life, he actually believed in the assimilation of a culture and not its total annihilation. In fact, Kublai was responsible for the first true unification of China and founded, short in Chinese terms, the Yuan dynasty, which ruled over China in, I guess, relative peace and prosperity for nearly 100 years. He was certainly a diplomat, a politician, and a nation builder, and he founded the city of Beijing and actually placed the first stones on the site of the Forbidden City, somewhere I intend to go one day myself. What a beautiful, beautiful picture that actually is. Now, Kublai Khan also promoted religious tolerance. He supported the arts, he fostered innovation, and very much encouraged trade. Unlike his grandfather, Kublai very much understood that trade and profit could, you might say, turn a man's head almost as fast as you could cut it off. And so under Kublai's administration, trade and commerce absolutely flourished. He extended the Chinese canal system to move goods around the various provinces. He promoted and policed the Great Silk Road, not the digital one, obviously, and held open a path for trade with the West, one that many of that time, lots of goods passed backwards and forwards, very lot of famous people, Marco Polo, others went back over that route. And in fact, he was so successful at promoting trade that he created a real problem for himself. By about 1280, trade was so good, his administration was running out of CISO. And that's the gold currency that was used at the time. Now, several previous Chinese rulers had actually tried to avoid this problem by issuing paper money. But gold really was the currency of the time, and trust was, I guess to use the phrase, in the hand of the beholder, not on this piece of printed paper. And so although several of those emperors actually tried, all of them failed to move from the gold standard to that of paper money. Now, Kublai Khan was, as I say, a Mughal warlord, and so his solution here very much matched his heritage. And whenever a merchant refused his paper currency, they were very publicly beheaded. And so, as you might imagine, even without Twitter at his disposal, word very quickly got around his community, and it was well known that it was trust his paper or die. Now, due to this very ruthless approach, Kublai actually created the world's first truly national paper money system, and it was a system that relied on his centralized trust and his centralized control. And this was trust and control that obviously was very prosperous for everybody, boosted trade, and of course, boosted taxes at the time. That was very, 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 very successful. And I guess as I sit here in Austin in my comfy office in 2018, I really have to ask the question, how much have things changed? Do we still trust in that same way today? Well, for the most part, the answer is actually yes, we do. There is no axe, but currency and trade is still very much conducted around a centralized currency model and system. And of course, I don't wish to allude that fractional reserve banking, that mouthful of a term, is in any way connected to 13th century dictatorship, but it's still fundamentally a system of centralized trust. And there's an intermediary that hands out bits of paper. And since the founding in 1913 here in the US, the motto has certainly been, in the Fed we trust. And until the recent cryptocurrency boom, the Fed really was the only game in town, so it's really no surprise. But currencies like Bitcoin that were once the exclusive domain of the geeks and criminals, you might say, it attracts mainstream investors. My grandma's got some. It's kind of extraordinary. And with a single Bitcoin valued as it is now in the thousands, it's easy to see why we might now instead say, in cryptography, we trust. Now, I don't want to get into the politics of the democratization of currency. It's the democratization of identity. But I do want to explain a little bit about how blockchain technology has introduced a new, completely decentralized, and that word should be in bold and underlined in your mind, a decentralized model of trust that has no single centralized authority. Now, my goal is to explain really in very simple terms as possible how that blockchain system works. For the crypto experts on the call here, you'll have to bear with me. For everyone else, let's look at the definition of blocks and chains. This thing we call distributed consensus, which is absolutely key for the identity use cases. And you can't really have a conversation here without also understanding mining and proof of work as well. But before we do any of that, we have to talk about the hash. That usually wakes a few people up, a few uncomfortable looks when you're with folks from marketing. What's Darren going to talk about now? Well, of course, I don't mean a trip to the West Coast. You'll be a little silly about it. Not a yummy breakfast at McDonald's, perhaps? Some McDonald's hash? No, of course. It's the cryptographic hash, obviously being rather silly here, the process of one-way encryption that's used to create tamper-proof online data. The crypto hash itself is very much at the center of everything blockchain, in fact, at the center of everything distributed ledger, and we'll come to that here in a moment. So let's take a quick look at how hashing works as a background. Now, the hash itself is a mathematical function that when applied to some input data, it's going to create a unique random digest, or often referred to as a fingerprint, as its output. Now, it's providing a one-way encryption process that is very, very difficult, time-consuming, and costly to brute force, to crack open, but yet it's very, very fast to validate. It's very fast to validate that a hash is correct, that we know the input data and we can share something. And this unique property allows for very reliable tamper-proofing of that input data without sharing it with a third party. And what that means is if I encrypt something and share both the encrypted text and the hash value, we can achieve what you might say is verification without disclosure. And this is absolutely integral to how things work. Being able to verify the integrity of something without sharing it with you, it's pretty much how much of this technology actually works. And those hashes are actually being used to fingerprint and verify blocks of data. Now, a block consists of some header information and a payload. Here in blue, the word SailPoint, and a SHA-256 hash, in the case of blockchain, a SHA-256 hash of that value. The first block in the chain is actually called the Genesis block, and it's a very special one that's put there when the system is very first created, when the very first block is actually published. Interestingly, the Bitcoin Genesis block was put down by the now infamous Satoshi Nakamoto. Who that man is, we do not yet know. And it included the text, just to read what you can see there in the circle, the Times, 03 Jan 2009, Chancellor on brink of second bailout for the banks. Quite a pertinent set of words and some very meaningful things at the time that Genesis block was first published. So it didn't really mean anything. It was just the content of that payload, which was then hashed. So after the Genesis block is created, every other block in the chain is chained back to the previous by including its hash. So the hash of block A is included in block B, and block B's hash is then a verification of the integrity of both of them. Very, very interesting property. And Bitcoin blocks also contain a whole bunch of other stuff, ordering and timestamping. And if you want to go and look at it, this is a screen capture of the blockexplorer.com site, where you can actually literally go and sit and look at blocks going by on the chain. It's actually fascinating thing to do if you're that way inclined. But the really important thing about this blocking system is the fact that they live in a chain. And the structure and the integrity of that chain and all of the content within it is used by capturing hashes of the previous block. So that is the integrity. And if anyone should ever tamper with one of the blocks, so mess with one of them, it would invalidate its hash and it would break the chain. And if you're an experienced security practitioner and you think in terms of breaking things, you might immediately ask the question, well, okay, so what's to stop me from breaking that one and then tampering or playing with or recalculating all of the hashes that come after it? Right? I mean, what stops me from doing that? There are a lot of very well-funded adversaries out there that may choose to do that. And this would be computationally tiresome, of course, but it's very doable. So you might say, hey, hang on, how does this work? Well, this is where the genius of blockchain actually comes in. First, you have to understand that there are multiple copies of the chain, and each is being hosted by a separate node in the network, not by one party, and that's very important when we look at some of the identity governance cases. And this is fundamentally distribution. So literally thousands of nodes, independent nodes, all maintaining and keeping charge of checking the integrity of a copy of the chain. And like I said, each is listening for transactions and creating new blocks and competing to be the first to publish that block to the network. Every node is actually competing in a giant crypto processing race. And the prize, the express goal, if you like, is to be first to publish. And when a node wins that race, listens for some changes, creates a new block, links it to its ones before, creates a hash, and publishes it, it's got to pass validation with the network. And unless a majority of the other nodes, the other people hosting the chain, confirm the integrity of the chain, the block isn't accepted. It gets disregarded by everybody else, and that is consensus, the consensus of the network. Literally thousands of independent entities agreeing on the cryptographic integrity of records in a chain. That's fundamentally what blockchain does. There is a little more. Nodes don't just get to publish a block, they have to solve a cryptographic puzzle to go with it. And this puzzle is what in the blockchain environment is called a proof of work. And in simple terms, a blockchain proof of work, it's actually a very ingenious system. It's basically a guessing game, and it's one that involves taking the block, adding some data to the end of the block. It really is a nonce, it's a meaningless text, it doesn't matter what it is, and then generating a hash of the block again. And this process is repeated again and again until a very specific numerical pattern is found in the randomness of the hash, of the output, of the fingerprint. And for the Bitcoin network, this is a series of zeros. Now, like I say, realistically, computationally, this is a giant guessing game. You can't cheat this thing. It literally takes hundreds of millions of guesses. I put a new nonce in, I add an A, I put a Z in there, I put a 1 in there, and I compute it every single time until the right format is generated. It's a race. And of course, when that happens, we're going to publish it. But this computational guessing game, well, it takes time and money. And to be precise, it takes 10 minutes to solve this cryptographic puzzle on one of the largest dedicated server farms in the world, the biggest thing we can put together, all the compute we've got that money can buy. It takes 10 minutes to solve that puzzle. And of course, that elaborate exercise burns CPU time, which consumes electricity, which costs real money. And so again, you might say, well, gee, when you've done that, what do they do? Well, as soon as a node does solve the puzzle, of course, it sends it off for validation to the rest of the network, because being first to file and validate wins the race. And if a block, of course, fails that validation, so they cheat, they do something wrong, they mess with the data, the nodes are going to ignore it, and the publishers wasted their time, right? They wasted their money, their investment. All that computation was a waste of time. And this process of puzzle solving, publishing, and hopefully winning for the block system is, of course, crypto mining. That's what all these guys are doing in their data centers in what seems to be the Nordics right now. So you might ask, why are they doing it? Why are these miners competing? Why are they investing their time and money in this? You can only really call it a giant crypto lottery, because that's what it is. There's no guarantee of winning. Why do it in the first place? Well, the answer is simple. I kind of alluded to it. They get paid, right? If their block is accepted by the network, they win. They're paid in blockchain. So quite simple. Next question to ask is, well, why did we design the system this way in the first place? You know, why do we need miners? Why set this puzzle? Why pay this price? What's the point here? You know, why are we doing this? Well, of course, for the blockchain system to work, it needs a community of participants. It needs nodes hosting that chain, right? Publishing blocks and validating the integrity of the system. And for a system without a centralized authority to succeed, it has to promote that participation in order to generate consensus, right? And, you know, a bit catchy, you might say consensus is the new oil in this sense, right? I mean, it really is this thing of great value that delivers trust in a system that fundamentally has no single centralized authority. Blockchain isn't the only game in town. The broader category here, if you like, is more commonly referred to as distributed ledger technology, or DLT. That's kind of what I'll call it for speed. It's a very active space. If we had some more time or interest here, it's a great place to go geek out on the various methods. It's very active, lots of math going in here, lots of different options and things to look at. But in the interest of time, I'm actually going to just point you a couple of examples. The first of that is it's the Hyperledger project. This is an enterprise-focused open-source DLT system, distributed ledger technology system. It's a complete software framework for building, developing, and maintaining that distributed ledger system that we described, right? You don't have to invent it every time. If you and I want to create one, we can use this toolkit. It's actually a large industry consortium that's working on this project, and that consortium and that enterprise interest really is helping to drive DLT into mainstream enterprise computing. The other example, just to throw a contrast out there, is one called Swirls. And in the Swirls framework, that chain is actually modeled as a graph rather than a linked list, and that actually has some very interesting mathematical properties. The graph approach is actually very interesting for its speed and throughput characteristics. Unfortunately, you might say, I say unfortunately because Swirls is actually a patented commercial framework as a software vendor. I can't fault them for that. A little bit of a downer if you wanted to share it, but it's still very worth taking a look at, and I'd encourage you to look at both of those. But the reason I chose those two is because they are both very good examples of what are called permissioned ledgers, not public ledgers like blockchain that are open to any participant. You and I can, we can be miners, we can host the chain, we can do, nothing stops us, it's completely open. But these are enterprise-focused frameworks that have a very specific access control model. And of course, that's where you're going to see me talk more about that, because that is an access control model that absolutely needs to be there for the enterprise use cases, and it's something that governance can help on. And I'll come back to that here in a sec. Now, obviously all super interesting, that whole blockchain example, but the question you have to ask yourself is, what does this mean for us in identity management? Why are we hearing so much about identity and blockchain these days? Obviously, our title was able to get a significant number of you to come. That word is much heard. But the question is, how is distributed ledger technology really more than blockchain changing our use cases, the use cases that I think most people on this call care about? Now, to answer the question, this simple picture really is a good start point. Distributed ledger technology does have the potential to change things in identity management. Let me say that first. If you're in the access management game, delivering identity proofing or authentication, over on the left side here, I'm going to talk more about that. It's game on right now. If you're not doing something here, you should be. And for us in identity governance, the use cases on the right side here are a little bit further out in the future, and I'll explain exactly why. But I do want to walk through all four of these very quickly here and just explain exactly what's happening. So the first use case to look at is identity proofing and assurance. And I focus here a little bit longer because proofing is very important. It's the process of confirming there is a relationship between a real person and a digital identity. In many systems, this is absolutely the root of online identity. And that term root is specific. Obviously, it's meaningful in our parlance here, but and it's very meaningful because it really is often the very first record that can seed the rest of a then related, connected online existence. Proofing can also be a big source of vulnerability and weakness, confirming that the right identity has the right access, as we always say in governance. Well, if you're not sure where it starts, that's obviously very, very difficult. And it also has to be said that the proofing systems that are in place today, and I'll show you one here in a second, are rarely in line with today's mandates of privacy by design. And most proofing systems, they're fundamentally manual, they're in person very frequently, and they require the disclosure and, importantly, the retention, which is what we should be caring about, the retention of lots of personal information. Now, before I give you a picture of how DLT is going to change this world for us, let's just very quickly look at, as I say, how this is done. I think most of you here today are in North America, so let's look at the Department of Motor Vehicles here in the US. Now, in order to obtain a driver's license here in the US, as you can probably tell, I'm not a native, I am a citizen of the US, but I'm not a native here. Here in the USA, this is how we do it, right? The DMV has a very specific identity proofing process, and here specifically in Texas, I had to turn up in person at a local office, and I had to wait in line for a number. I then had to bring proof of my nationality, my national status, my address, and my date of birth, of course. And a well-trained DMV employee went through a manual process of document resolution, validation, and verification. I'm not going to go into those much more, but they are the three academic phases. They took my photograph, and I got my driver's license. That is my actual driver's license from 2010. Pretty scary picture there. I don't know quite what was happening, why I look like that, but there it is. I had to carry that around for 6 years, but that's my, my fun, I guess. But the point here really is, though, that the proofing of my identity was a very manual process. I had to give up all kinds of PII, right? And the state of Texas now keeps those in a file somewhere, I'm absolutely sure. And this proofing process involved that centralized authority, right? It created a single point of trust. And it costs lots of money. This is not a cheap process. And all I got for this was a plastic credential. And it's a plastic credential that's no use online, right? It doesn't buy me anything. But of course, there's been much discussion about this over the years, that the DMV process could result in the creation of an online identity rather than that piece of plastic. But the trouble is, even if they did, I'd still only be proofed with a single authority, and I'd still only have centralized trust, right? It would still be the DMV. That single provider would still own all my PII, right? I've given it to them, and I'm not in control. Even if it was, I'm not in control of my privacy or my data. And this is exactly where distributed ledger technology can help us, and it can provide a system of proofing and verification that doesn't have a single point of failure. And to explain how this works, the ledger becomes something that Gartner refers to as an identity trust fabric. I love that term. It sort of really describes it. And this trust fabric is basically a permissioned ledger that stores information on identity proofing and validation events. So it's a shared resource. And you might say the miners that host the chain in this type of a system, they would be institutions and vendors, most probably likely government entities, or very clearly the potential for strong communities of interest to participate. And they would all be on board for this in order to deliver better onboarding, shared validation, stronger assurance, and enhanced privacy for their subscribers. There's lots of good reasons. Now, the subscribers in this system, strange little shape on the right there, would be people, likes of us, consumers of internet services, you might say, that are issued with a digital identity wallet. And this wallet would be basically a private vault, and it would contain personal information that I put there, and we'll talk more about that here in a sec, that would then be used to register and proof with trusted third parties. Now, these trusted third parties would be those organizations that specialize in establishing online trust. They are fabric owners, you might say. And in practice, as I said, commercial custodians and government agencies really are the people that are most likely to be in that. And at the point of registration, the consumer, I'm going to choose what information to share from my private wallet. So I'm going to take that awful picture on that piece of plastic. I'm probably going to present a notarized high-resolution scan or something of it in this purely digital environment. Then based on my user-controlled security settings, that third-party trust vendor is going to validate and verify the information in their own way, and then they're going to broadcast a record of the proofing event to the ledger. The actual data from my wallet, it's not on the chain. It's not been put there. Only a hash, a verified hash, a block of the encrypted artifacts would be stored in the blocks on the chain. They don't need my data. They have a hash of my data. That's kind of how it all fits together. Then when the identity is presenting itself for registration at a relying party, the relying party can simply consult the trust fabric without going back through proofing with me. The trust is in the network, you might say, not back to the individual consumer. And then when details of new registrations happen and individual trust decisions are made, they could also be added to the ledger. They probably would be. And this is going to further enhance the trust fabric. You might say sharing those relationships creates shared trust as they occur. And this process is going to carry on for the life of the account. And it's going to record the decisions and slowly and surely increase great word, reputational assurance for the identity. We could have put that in the title too. And this is all going to be carried out while the subscriber is going to remain in control. I'm still in control of what's getting shared with which provider. There's great technology available to do that, and I'm in control of what's being shared. Now, if we can deploy this system at scale, it really could represent the true democratization of identity. No single authority, distributed trust, and user-centric privacy by design. And that has to be something that we should all aspire to. Now, the next identity use case I want to come to quickly is around federated single sign-on. And if you're a specialist in this space, you'll know that since the first SSO was deployed, more than 20 years ago, access management has been struggling with single sign-out. Not on, out. And the idea of a universal sign-out, it's just turned out to be very tricky to implement, and it's really not yet been deployed at large scale, internet scale, you might say. And so when an SSO provider kills a session and wants to signal that fact to other parties in the trust chain, they've really today only got two ways of doing it. Well, one, they can go through what is called the front channel, and they can use a clumsy set of browser redirects and bounce you around all of those shared sessions. I think technically my colleagues and partners in the SSO space would refer to this as a crap user experience. Obviously, but it isn't a great experience. You get bounced around. It doesn't really look great. So front channel's not good. The other option is to go through a tricky process of direct server-to-server communications, or what's referred to as the back channel. And this turns out to be very complex to implement. Certainly at scale, and in a multi-vendor federated system, it's just not yet been achieved. So it's blockchain-related technologies, DLT, that can come to the rescue here with a high-throughput distributed session ledger. The idea of the session ledger is that the state is maintained as a series of transactions on the shared ledger, right? It's starting to look very similar. And when one IDP does an authentication event, it simply writes an entry, not details of who I am even, a hashed, shared, validated entry for everyone else to look at and validate. And all of the participants in the system can then busily maintain their session and state by reading and writing transactions back onto the chain. And when a relying party does want to globally sign you out, they simply write that transaction onto the ledger and everyone else can act upon it. Pull them from the chain, log out, simple, effective. So distributed session management, great use case for blockchain. Now, of course, proofing and single sign-on are examples of cool things that, like I said, are on that left side happening in access management. So What about identity governance? My space, our space, the reason you're probably here. How is DLT technology setting up to change things for SailPoint? And you might say, is blockchain the new governance fabric? Well, hold that thought. Let's jump in and I'll show you what exactly is possible and, more importantly, what's practical and likely to happen in the short term. So as I highlighted on my picture, these are use cases over on the right side, and they are audit logging and governance approvals, two very low-hanging fruits on that side. I'll quickly bounce you around what these are and give you a look at where we see this happening in the future. So that first use case is audit logging. It's actually quite easy to understand. It can start to look very similar when an identity governance service, your SailPoint service, receives a provisioning request. Instead of writing an audit record into an internal log file like we do today, it could be encrypted, could be popped on the chain. Or when maybe a manager signs off on a certification, rather than keeping that artifact offline, if you like, private to our database, to our system, it could be published on the shared ledger. Again, we don't have to share what was approved, we can share a hash. And of course, we'd want to use some open standards here and represent these provisioning actions in a standard, and of course that standard would be SCIM. I hope everybody here has heard of that, the System for Cross-Domain Identity Management, our very own RFC 7642. So perhaps I can claim a little marketing here for the term SCIM chains, a decentralized and shared audit log for provisioning and governance actions in SCIM. The other interesting use case for us to quickly look at is distributed approvals. I think you're going to see how it's going to look. Well, let me just first of all say, complex multi-party approvals within a single domain, that's what we do every day. Motherhood and apple pie, right? I mean, who doesn't do that in identity governance every single day? But how would this work across multiple service domains? Not a single identity IQ environment, you might say. And here again, that permissioned ledger could hold the key. When the first domain finishes its part in the approval process, it's simply going to publish a transaction on the ledger. And then when a second governance service domain is interested, it pulls that transaction from the ledger, validates it, and kicks off its own approval processes. Simple. And I think this simple use of DLT technology, you might call it the approval ledger. Again, maybe a nice term we can adopt. Identity governance approvals built on a shared ledger. And so for us, I think really these two use cases do represent the likely first steps into identity governance built on distributed ledger technology. It's kind of cool stuff. It's a great place to geek out, but I'm going to be really frank with you. It's not something that's on our product roadmap today. And you might say, well, surely, SCIM chains and approval ledgers, something of great interest, and it is something that we've been prototyping in SailPoint Labs, but we're just not really seeing a commercial driver for this today, multi-party cross-domain approvals. But I would say if you are interested in this technology, if you're interested in this approach, and it's an area that you think you would be interested in, please drop me a note. I'll have my details at the end of here. We'd love to hear from you. As you know from SailPoint right now, if it's not customer relevant, we're not going to do it. Right? So that's just where we stand. So. Well, looking at the clock, nearly out of time. We covered a lot of ground here. Out of my time, I guess. We've still got plenty. I want to get done early. We covered a lot, right? We went from that 13th century warlord to the future of identity governance built on blockchain. Well, quite a journey. And so before I finish, just a final thought, really. And it really says where I think this is truly going. And it is the fact that as this technology, as blockchain and distributed ledger in enterprise, in hyperledger, in swirls, gains traction, and enterprise business systems make use of it, then it's going to be our job in identity governance to manage it. Right? That's what we do. We manage, how many times have I said this? We manage systems of authentication and authorization. Right? That's what we do. And so in practice, This means governing permissioned ledger, and so far I'm pleased to see that permissioned ledger systems seem to be trending towards a very traditional access control model, right? They have an access control list, they have users, they have entitlements, right? Things that you can provision. So for us, this simply means a new connector. And so when we do snap in a Hyperledger API connector, it's literally business as usual, right? Very little's going to change. We're going to answer the same questions. Who has access to that ledger and why? How did they get it? We're going to provide automation, security, and compliance for the blockchain and DLT-related systems. And in doing that, we're going to harness the power of identity for all systems. Wherever they run, this is a great phrase, wherever they run, whatever they're based on, and however they're delivered. That's the story. I want to now pause. I see some questions. That's great. We love questions. I've got a couple of canned ones. They're always boring, so I love your questions first. So let's go there.
Great, thanks, Darren. Okay, so our first question: why is proof of work required for identity-related distributed ledger systems?
Ooh, okay. Okay, that's a good one. I think what I'll have to look up where that question is from, because it's a good one, because it really alludes to a view of where we think this is going in permissioned ledger systems. And you might say, if it's a closed loop, if it's not a public system, surely we know everybody. Do we still need proof of work? And that is actually true. There are many other ways of assuring the integrity of the participants. We choose proof of work in blockchain examples because it's public, and there's no better way to have people behave than to have them controlled by their money, right, which is what we get with that proof of work. Hopefully that was well explained. But so it is true to say that it isn't completely required, and there are some other approaches that are used in some of those enterprise systems. So good question.
Got it. Thank you.
Okay, so could we address the potential effects of GDPR's related issues to forgotten identity with distributed ledger systems? Wow, great question again. That is obviously a hot topic for everybody, and it's one that the industry is having to take very seriously. Where are my personally identifiable information? Where is my entire personally identifiable information being stored? As I've hopefully drawn out for you, in a permissioned ledger doing an identity use case, we don't actually, the identity information isn't reversible, right? So I can validate something if I already know the information, right? So if I wanted to pull my block off the chain and say, hey, is that driver's license correct? And I have the driver's license, I can re-encrypt it and check its hash, right? And so the net is the personally identifiable information under today's legal definition isn't being stored on the ledger. And that's kind of cool. I personally question there is a very long legal wrangling debate here about whether if I can apportion it back to its original source, then it is still identifiable. But in this case, I believe the current legal definition is it's not, so it doesn't actually count. So, good question. Can blockchain scale to non-human device identity permissioned levels? Another great question. Yes, absolutely. And I think where I see identity and blockchain outside of great marketing or in those two use cases that I've already drawn out being actively researched for good commercial benefits here, I think in an IoT world where we see very, very rapid high transactional throughput integrity required, I think the technology is very well cited and approved and potential there. I think the notion of a proof of work, guarantee integrity from external parties, you have to question whether that really applies. Yeah, my refrigerator and my Nest, you know, I don't think that's what we're talking about. We're talking about medical devices, mining devices in enterprise use cases, and I think they're going to be on permissioned and private ledgers anyway. But again, that's not a question of its scalability. I do think it's very applicable there. And another question, oh, I can actually see who they're from. No, I shouldn't say that, personal privacy. I can see who they're from, you can't. Have you seen identity management systems being used to manage distributed data, such as in an IPFS storage? I haven't myself. If somebody has, I'd like to. Really, one of my great asks for anyone listening to this webinar, if you're seeing true identity management as we would define it today, in access management, or more importantly, identity governance related use cases, I would love to hear about them. I'm sure the tech is running out across the IT stack. Isn't this just what we live for? Some new tech, new stuff to understand, right? So it's being deployed in many places, and that's a use case I'm not currently familiar with myself, but it probably is very relevant. And then finally, do we really see a business case for the use of blockchain in the near term? And why is this topic of interest? And why is this a topic of interest if there's no business case for it? I think I kind of alluded to that a moment ago. We live in a world, well, certainly we do in SailPoint, where innovation is king. You know, it's part of our DNA, and if there's something, you're only ever innovative by paying attention to things that are new. So I think innovative companies have all jumped to look at blockchain. And like I say, from a security, from a crypto, from a system analytics perspective, this is really interesting stuff. You have to look at it. And so the question is, I'm not saying for 1 second it's not business relevant. What I am saying is I think there's going to be a number of, in banking, in healthcare, I think over the next 5 years, we're going to see IT infrastructure leverage this, just like cryptography, like Java. It's tech that's just going to be deployed. It's not revolutionizing anything, really. It's just more tech. It's a really cool tool you can use to do some cool stuff. And what's going to happen is systems are going to be generated, and their integrity, their access is going to be affected by the blockchain. I'm not even going to say controlled by it. And then, as I say, what are we going to do in systems management, in security, in governance? We're going to manage those things. And so I think they are going to get into mainstream business computing. And I just don't think it's something that's going to revolutionize what we're doing in the identity governance plane, if that makes sense to you. Yes, there's some use cases there, but it's really going to be managing others that are doing it. And then I think one final quick question, and then I think we'll try and give you some time back. There's been lots of questions, so sorry about that. Can this be implemented in a private way rather than globally versus global sharing? And would it be reasonably and cost-effective for a company to do it themselves? Yeah, it's another great one. It comes down to that community of interest. Like I said, if you're a SailPoint customer, just stop for a second and ask yourself the question: who do I want to share my log data with? My identity IQ log data with? Who do I want to have doing approvals that can't log into my system through the mobile app, through all the ways we have, right? Who is outside of my system of domain knowledge and integrity that I want to interact with? And it's very few. Those cases don't seem to exist right now, so hence why I say they're rare. So, you know, it's hard to say that a single customer, a single entity would see that value. Consortia, I could see, you know, large manufacturing communities that want to share, that don't share, and I'm going to use my terms, right? And you know, an identity now instance that aren't sharing it. Yeah, I could see it, but yeah. Great, well, awesome. Thank you all very much for the questions. We didn't get to any of our canned ones. I love that. Let me just pass back to Shay for some housekeeping.
Great, thank you. Everyone, thank you for joining us today. Keep an eye out for an email from us tomorrow that will include a recording of today's webinar. We'll also be sending you a complimentary ebook that will kind of dive into more what it means to have an identity-aware organization, from infrastructure to users and everything in between. So keep an eye out for that. If you'd like to learn more, go ahead and contact us using the information on your screen, and we'll get you in touch with an identity expert right away. Darren, thanks for your presentation. Thanks everyone who joined us, and enjoy the rest of your day.